So the second topic in one-dimensional motion that we're going to cover is velocity. Velocity is often can be referred to as speed as well, even though there is a difference between the two. Okay? Velocity is determined as the distance traveled per unit of time, and it also has a direction. Right? Our equation for velocity, now I'm going to use a lowercase v here to indicate velocity, is going to be our displacement divided by the time that takes place. Okay? Remember, displacement is a change in position. So really, velocity deals with how fast you are traveling for your displacement, right? And remember that displacement is position final minus my initial position over time. So this is a way that we can rewrite our velocity equation in terms of velocity equals final minus initial position divided by the time that it takes. Okay? Now, velocity is a vector. And again, vectors have two components to it. Right? It has both a magnitude and a direction. Okay? The magnitude in terms of velocity, that tells us how fast, right? If we're talking about the rate at which something is moving, how fast is it actually moving? That's what the magnitude tells us. The direction basically tells us which way. Okay? And so if we think about this, if we have some examples, if we had an object that was rolling in this direction at positive 10 meters per second, okay? The 10 tells me how fast it's moving, 10 meters per second. Now, to understand that, that means in 1 second, it would have gone 10 meters from here to there. A second, it would have gone 20 meters. A third second, it would have gone 30 meters, right? So if it started at the origin and it had a velocity of 10 meters per second, after 1 second, it would be at 10 meters. 2 seconds, 20 meters, 3 seconds, 30 meters, okay? Each time frame is the same, 1 second. 1 second. 1 second. If we had a second object started here and traveled this way, that would be a negative 10 meters per second, okay? It would start at 20. After 1 second, it would be here at 10. After 2 seconds, it would be here at 0, because it's changing its position by 10 meters each second, right? Now, to compare these two, they have the same magnitude of velocity. They're both going the same speed. Speed is typically thought of as velocity without a direction. Now, I know we could get into, well, speed is really distance over time, and velocity is displacement over time, and distance isn't the same as displacement, right? But we're talking about things in one dimension, and more than likely, we're just going forward or backward, okay? So we can really understand that velocity is speed, but it's speed with a direction, where speed is velocity without a direction, okay? And they're going to be exactly the same as long as my distance and my displacement are the same. So here, we have the same speeds. They're both going 10 meters per second, however, their velocities are different, right? This one is a positive velocity, that one is a negative. And so we understand, we will typically use the rightward direction as the positive direction, and the leftward direction as the negative, right? Same as upwards is typically positive, downwards is typically negative. It doesn't have to be, but that's typically how we're going to set up problems in physics. So let's understand what this equation can tell us a little bit more, just so we have a little bit deeper of an understanding of what velocity is. It's how fast you're going, right? It's the distance traveled per unit of time. So what does this tell me? If we break this down, remember this delta stands for change. This x stands for position. T obviously stands for time. So what does velocity actually tell me? It tells me how much my position changes each time interval. If something's going 10 meters per second, my position is going to change by 10 meters every second. If something's going negative 10 meters per second, my position is going to change negative 10 meters every second, right? If we had an object starting here at 25, well, each second, its position needs to change by negative 10 if it's going this way. 25 to 15, that's negative 10. 15 to 5, negative 10. 5 to negative 5, negative 10. My position changed by negative 10 meters from here to there to there. What we'll do in the future is we'll look at how we can graph velocity on a position time graph or on a velocity time graph, or how we can actually read velocity from an acceleration time graph. But for what we need to understand now is just the basics idea that if something is traveling with a velocity, it is moving either left or right, up or down, depending upon the direction, as well as we need to understand how it can tell us how much our position changes for each time interval.